Okay, now, points of inflection, it's similar to stationary points, right? First you got to find it, but then you don't really determine their nature. Instead of determining their nature, you find and then you confirm. Okay? Find, confirm. Okay? Finding works much the same way. Okay? How do you find a point of inflection? First step. What do you solve? What equation do you solve? Second derivative is equal to 0. Okay? Solve. Okay? Now eventually, if we find the point of inflection, you are going to have to substitute that back into y to actually get the coordinates. Okay? But before you do that, you actually want to confirm that what you've got is a point of inflection. Okay? So this is my second part now. How do you confirm? Well, we actually mentioned this just before, right? You need to test the second derivative on either side. Okay? So what you must have is the change in concavity. Okay? Check. Oh, that's nasty. Okay. Yeah, it's a new pen. Anyway. So, am I done? Am I done? I've solved this, and I've checked it, I've confirmed it, and sure enough, it checks out, it's a point of inflection. Am I finished? There it is.
Test again.
You've got to look again. So this is actually, I'd put this under 3, right, when you're trying to find things, right? Look again. What do I mean by look again? Well, graph it. Okay? You have a general sense of what this thing looks like, okay? And what will come out is particular, points of inflection that don't come up for this. Do you remember what our counterexample was? I think the most often quoted one is the cube root of x. Sorry, that's a 3. Okay, do you remember what the cube root of x looks like? It's concave down on this side, and it's concave up on this side, okay? At the origin, where you can see there's a point of inflection, change in concavity, okay? The first derivative and the second derivative, they don't exist at that point, okay? So therefore, you've really got to be careful with these ones. If it's a textbook question to say, find the points of inflection for this, okay? Because you'll solve for this and you'll find there's no solution and then you pack up and go home, okay? And you've missed the point of inflection. So, solve, confirm, but also actually have a think about what this thing looks like, okay? Yeah, yes you do. Yes you do. Okay. All right. So there's points of inflection. There's stationary points. Yeah. Okay. So if the question was find any points of inflection for this, okay, and the question didn't actually say graph, then absolutely, like I'd do this, and it looks terrible, and there's no intercepts or anything on it, but it's enough to see. Oh yeah, I've plotted points and I've seen the concavity here, and the same on the other side. So I'd say, look, there is a point of inflection.